All right, today is the last time you'll ever have to take notes in honors free calculus. Congratulations. Okay. Now, before we take notes for the last time in honors free calculus, I do want to I want you to recall something from our matrix chapter.
No, I wasn't.
Matrix
Okay.
is fun.
Okay. Right. So back in our matrix chapter, we took a determinant. Remember that? Okay. So, and we took determinants of square matrices. So I'm going to remind you how to take the determinant of a 3x3 matrix because we will need that to help us with cross products. Okay? So,
Is there like some rule too that you can't multiply it or add it or something? It's not.
There was one question about these on the ACT and I definitely missed it.
okay, so here's a 3x3 matrix, and since it's just like the slashes, that means we're taking the determinant. Okay? All right. Does anybody remember how we do this? No. We copy paste the first two columns. We kind of do both.
Or you do the diagonals. You multiply and then you add them.
Okay, so we do the diagonals. So we go down first. So what's this product?
0.
Plus,
3.
plus,
-4.
-4. And then we subtract the up diagonals.
0.
Plus, plus, -4. So we have -1 minus -4, which is 3. Okay? That is how we find a 3x3 determinant. Criss minus cross. Alright? Come back to you, okay? We'll do it plenty of times that you will remember by the end of the day. Okay? Alright, so what does this have to do with anything related to vectors? Let me show you. Okay? So we can take the dot product to get a number, right? Now we can take vectors in 3 dimensions. We can take their cross product to get a vector. Okay, so we have 2 different products, a dot product and a cross product. So here I have vector u and vector v. Okay, notice they're 3-dimensional vectors. Okay. The cross product is what we get when we evaluate this. Okay, so this is set up like a determinant. We're not going to call it a determinant, but that's how we're going to solve for our cross product. All right, we're going to put I, J, and K right there. And then the component of U in the second row, the component of V in the third row. And we're going to basically find the determinant by doing our criss minus cross to get our cross product. Okay, so I'll let you write down what you need to. Okay. The order in which you put your vectors in is important. Okay. Notice that this is U cross V. U is in this second column, V is in the third column. Okay? U cross V and V cross U are not the same. This is not a commutative operation. Alright, so it is important that whatever vector comes first is in that second row.
So how do you get IJK?
IJK, that is always going to be your first row when you're taking the cross product.
Where will you be getting the IJK?
It's just IJK. Like there's not going to be any numbers in front. this is how we get a vector out of it. So by the time we multiply out our determinant, okay, we're going to be left with a vector in terms of I, j, and k. All right, so this is how we're getting a vector out of the operation. Okay, are you ready to see an example of how this works?
Yes.
All right. Here is U, here is V. Write them down. All right, so when we take U cross V, okay, you're going to set up your matrix here with I, J, and K as your first row. We're taking U cross V, and since U is 6I plus 2J plus K, then your second row is 6, 2, 1. Since V is I plus 3J plus K, what's our third row? 1, 3, 1. Okay. So now we need to evaluate this like our 3 by 3 determinant. All right. So we copy paste the first two columns. Okay. We're going to do Chris minus cross here. So what is this product? 2I. What's this product? So plus J. What's this product? Plus 18K. All right, so there are our three products with our diagonals going down. Then we will subtract our diagonals going up. So what's this diagonal?
2K.
2K plus 3I plus 6J. Okay, now it's a matter of combining like terms. Okay, so we better do this in order. If we combine the i's, what are we left with? Negative I. We combine the j's. We have j minus 6j.
5J. Negative 5J.
And our k's, we have 18k minus 2k.
16K.
And there's the vector that results in u cross v.
This difference is that you have to put the V in the second line instead of the U.
Yes, so now when we take v cross u, when we set it up, what's going to be different than up here? Okay, so the v is going to have to come first here and then the u. So when we set up v cross u, we still have our I, J, and K here. But now V will come first, and then U. Are we going to get the same thing? No. But what we get is very interesting. Okay, so help me out. What's the process? Copy and paste the two columns. Now what? Okay, so our cross. So here is 3I plus 6J plus 2K minus plus 2I plus J. So what is V cross U? 2i plus 5 plus j minus 16k.
They're opposite.
They are opposite. Do you think that's a coincidence?
No,
Maybe.
probably not. Like that.
Okay. First of all, are there any questions on the process of the cross product? Okay. We have all taken note that these two are opposite. That will always happen. Okay. So while they're not the same, they are opposite. Okay. So if you know V cross U, you know U cross V. It's kind of nice. Save you some work if you have to find both. Okay. So I want to go through a few properties. You don't have to write these down. They are in your book. We can just talk about them. You may want to write down that U cross V equals V cross U. That may be beneficial for you. Okay. Now these other ones, we kind of talk about these same similar properties every time we've talked about vectors. Okay. So if we have U cross the sum of V and W, okay, then that's the same. We can, since this is a cross product, we can think of this as distribution. So that would be the same as taking U cross V and adding it to U cross W. Okay, just distributing that cross product through. Here, okay, we have C multiplied to U cross V, where C is a constant. Okay, since this is all multiplication, C can be multiplied to one or the other before taking the cross product, and that would mean the same thing. Okay, but let's be honest, it's probably going to be easiest to do the cross product first and then multiply by the constant later, so you don't have big numbers in your cross product. Okay. Okay, if you take the cross product with a vector and the zero vector, you're going to get 0. Every time you do a multiplication, you're going to have 0. Okay. U cross U is 0. That's interesting. Okay.
Makes sense.
Why does it make sense?
Because one side is negative, one is subtracting a way good.
So you're subtracting all the products that you just took, basically. Would anybody like to see that actually worked out?
Oh my.
It won't take us too long.
We're being positive and trying to get through this.
So vector U was 61. Okay, so when we take our product, we get 2i plus 6j plus 12k, and we'll subtract, just like Joey said, 12k plus 2i plus 6j. Okay, we get the same products here as we do here, so we subtract them and they become 0. Okay. And then here, U dot V cross W is the same as if we do V cross W and take the dot product of that with U. That's kind of interesting, right? But it's still, since we have a dot product and a cross product, they hold those same properties as like multiplication with our real number system. Okay. All right. Okay, we're going to work with some geometry concepts, okay? Really, vectors are kind of a part of the geometry world, but we're going to work with some angles and then some shapes, okay? So first of all, when we find U cross V, or V cross U, either way, then that cross product is going to be orthogonal to both U and V. Now I know my picture here has A's and B's. I hope you can understand still understand the picture. Okay, if we have two vectors, okay, no matter where they are, when you find the cross product, you're going to get a vector that is perpendicular, or what we call orthogonal to both of them. Okay. So this picture, you can see that our vector A cross B perpendicular to A and perpendicular to B. So from our previous example, we had U was 621 and B was 131, and we found the cross product, correct? Okay. How do we know if vectors are orthogonal?
No. You find angle between both products.
There it is. Okay, if we go to find the angle between them, okay, before we even get there, if the dot product is 0, that's going to make our angle 90 degrees. So if our dot product is 0, that is proof enough that our angles are orthogonal. So let's check this out, all right? What was U cross V from our previous slide? Okay, so if we take the dot product of U and U cross V, then we get 6 times -1 plus 2 times -5 plus 1 times 16. Hey, look at that. Okay, I would like you to find me the dot product of V and U cross V. Just the dot product of this guy and V. Are we getting 0?
Oh, no, okay. I'm sure you're right.
You get 0? We get 0. So both U and V are perpendicular to the cross product. We can do the same thing with V cross U and the vectors U and V. Okay, it's going to be the same thing. What you will be asked to do in your book, there will be a couple of problems where they will ask for the cross product, and then for you to verify that it is perpendicular to U and V. So remember, anytime I ask you to verify that vectors are perpendicular, finding the dot product to be 0 would be proof enough. Okay? So anytime I ask you to verify that we have perpendicular vectors or orthogonal vectors, cross product or dot product is 0 is enough. Alright? Okay? More fun with geometry. Okay? I don't know what happened. Okay? The magnitude of U cross V will actually give us the area of the parallelogram if U and V make the adjacent sides of our parallelogram.
Is this supposed to be the absolute value of A cross B as well?
No, it's supposed to be magnitude. Okay, because A cross B is going to give us a vector, but by finding the magnitude of that vector, that's actually the area of the parallelogram. Okay, now there's this nice proof, long proof, that I could go through and show you why that is, but I think today we're just going to accept it.
Yeah.
Okay?
Good idea.
Okay. All right. So I have a parallelogram. with adjacent sides of vectors 1, 2, 2, and this would be the vector 1, 0, 1. Okay, be careful when there's only 2 letters, one is missing, that means it's a 0. So what we can do is find the cross product. Really doesn't matter which cross product because we're going to take the magnitude, all right? And the magnitude of both cross products would be the same since they're just the same but opposite, all right? So if we take U cross V, we have I, J, K, 1, 2, 2, and you told me this vector was 1, 0, 1. Okay, you find me the cross product. Jenna, what did you get?
2I plus J minus 2.
Agree, disagree?
Agreed.
Minus K.
You got minus K?
I got minus 2K.
Minus 2.
Like 2K15. Oh, that's funny.
Oh, no, minus 0.
You found it?
Yep.
Okay,
I can tell.
Yeah.
be careful when you have zeros thrown in there. Zeros make it nice, but for some reason, when we're working with determinants, it's really easy to forget that when you multiply by 0, it's 0. I find that students make that mistake a lot. Be careful, okay? So now, if we want to find the area of our parallelogram, then we're going to find the magnitude of U cross V. So that means we're going to take the square root of 2 squared plus 1 squared plus negative 2 squared. And what would the area be? Square root of 9, which is 3. A lot easier than finding distances and using, yeah, maybe not. Okay. One last thing. You ready? The last new thing you'll ever learn in pre-calculus.
You're gonna say you're gonna learn. I was like,
No, in pre-calculus. And then I'll send you on your way after your test. Okay, a triple scalar product. Okay, so a triple scalar product is when we're going to take U dot V cross W, or really in any order. Okay, well, let's stick with U cross V, U dot V cross W. Okay, so then we can look at here. Instead of finding the cross products to get a vector and then taking the dot product of those two vectors, we can actually throw all 3 vectors into that matrix and find the determinant to get us that number. So this is saving us some work. Okay, the cross product gives us a vector, and then the dot product between 2 vectors is a number. So instead of having to do 2 different products, we can throw all three vectors into our matrix and find that dot product. Alright, so U dot V cross W, also known as our triple scalar product. We're going to take this 3 by 3 matrix and we're going to make it 2, 0, 1, 3, negative 1, 2, and negative 1, 5, negative 2. So then to evaluate this determinant, right, copy paste. We're going to do all of our products here. So, going down. Help me out. 4 plus. Okay, and then we're going to subtract the products. 1 plus. So we have 19 minus 21.
Two. Negative 2. You ever see that vine? No, literally, I just said it right away.
All right, and that's our triple scalar product. And here's your last book assignment. This is actually the last assignment that will ever be done out of your book because we're getting new books next year.
So can we like,
Wait,
can we do our assignment?
Wait, can we burn our books? Can we draw all of them? Can I keep my book so I can burn it?
So like all the high schools.
That's easy.